All right, so now we're going to start looking at permutations. It's another way to combine things, different elements of a set. Permutation, by definition, is an ordered arrangement, so the order is important, of items in which no item is used more than once and the order matters. So you can't repeat any of the elements, and the order in which they occur is very important. Each ordering counts as an individual permutation. Give you an example here. I've got my 5 favorite movies. These are actually my 5 favorite movies at the moment. They're subject to change, of course. There's some honorable mentions I didn't put up here. I don't know, from time to time the matrix slides off and other things pop in, but that's going to be it for right now. Anyway, so my 5 favorite movies in order: The Dark Knight, the one with Heath Ledger as the Joker, my favorite all-time movie, awesome movie. Apollo 13, if you haven't seen that, with Tom Hanks and Kevin Bacon and Gary Sinise and Bill Paxton, it's a great movie, excellent acting, historically pretty accurate, inspiring movie. Rocky 4, can't be Rocky 4, where at the beginning Ivan Drago defeats Apollo Creed, and then Rocky gets his revenge at the end. That's an awesome movie. Anyway, some of you may be thinking, why did you choose Rocky 4 over Rocky 1? I know, but I love Rocky 4. The music makes the movie too. The Hunger Games, the first one, they're all good, but the first one is the best. And of course, The Matrix kind of stands alone. I'm not a big fan of the other Matrix movies in the series, but the first one was mind-blowing when I saw that as a teenager. So anyway, these are my 5 favorites. And now let's say, for instance, I wanted to sit down one weekend and binge watch all 5 of those movies. That's probably, 12 hours, 15 hours worth of movies right there. I don't think I would ever do that, and I never have, but in a weekend anyway. But let's say I did, and I wanted to watch them, but maybe I didn't want to watch them necessarily in this order. I wanted to pick, kind of randomly. Maybe I wanted to go Apollo 13 and then Hunger Games and The Matrix and Rocky 4 then The Dark Knight. There's lots of different ways you can order the watching of those movies, but one thing I'm not going to do is repeat one of the movies. I've already got 12 to 15 hours worth of movies here. I'm not going to watch one of them twice. That'd be ridiculous. So not going to repeat any. So this would be considered permutation. Whatever order in which I watch them is one of the possible permutations of those movies. And so a permutation is an ordered arrangement. So the order is important. Each different ordering is a different permutation. And again, none of them get repeated. So you're using all 5 of them in this case, all 5 of them up without repetition. Okay, so perhaps the order I want to watch them in, let's say I'm going to abbreviate these: Apollo 13, Hunger Games, Matrix, Rocky 4, and Dark Knight. Okay, let's say I wanted to go in that order. Well, that would be one permutation. Let's say my wife is like, no, I don't want to watch them in that order. She'd probably go with the Hunger Games because I think she'd enjoy that the most. Maybe Dark Knight, Apollo 13. She's not a huge fan of Rocky and The Matrix, so I'd probably maybe she wanted to watch them in this order and she'd skip out at the end. I don't know. And so that would be another permutation, right? Now the question is, how many permutations are there? How many different ways could we watch those movies, get them all in without repeating them? And this is not easy. Basically, at each position in the ordering, you have a different number of options. And so we're going to use the fundamental counting principle in conjunction with trying to figure out how many options we have at each step. Okay, so in the first slot, I guess we'll say movie 1, you have how many options? Well, 1, 2, 3, 4, 5. We have 5 options, right? So 5 options. Actually, I'm going to group these together. 1. So in movie 1, you have 5 options. Let's say I picked Apollo 13. I and that's the one we watched. Well, the second movie, we can't repeat that, so we have 4 options, right? So movie 2, 4 options. There's only 4 left. Once I take Apollo 13 out, there's only 4 movies left. Let's say I chose The Hunger Games then. Okay, once you take Apollo 13 and Hunger Games out, there's only 3 options left. And you can see how basically after each movie you have 1 less option. So at the, so the 4th movie, there's only going to be 2 options. And then finally the 5th movie, once you've used up 4 of the movies, there's only going to be 1 left. So there's 1 option. Okay, now the fundamental counting principle that we just learned about would tell us that the total number of outcomes is just going to be the product of all these numbers. So the total number of permutations is found by multiplying 5 times 4 times 3 times 2 times 1. That's the fundamental counting principle at work in this particular case. Okay, well, 5 times 4 is 20, 3 times 2 times 1 is 6, 6 times 20 is 120. Right, so this is 120 permutations. All right, cool. Now, do we have to go through all that work every time? Well, the answer is really no. Once you know the number of elements in the set, you can immediately get to the answer, not by having to break it down, subtract 1, then multiply. But we have a shortcut for this in mathematics. This sequential multiplication of a number times 1 less, basically every natural number less than that number multiplied together is called a factorial. Okay, and so a factorial is the product of all the natural numbers up to a given number. So I want a different color. So a factorial is the product of all natural numbers up to and including a given number. Okay, so what does that mean? Well, if I had, and the factorial notation is an exclamation point. It's kind of a cool notation. So if I had 5 factorial, 5 exclamation, it's like saying 5. Okay, I don't know, weird. Anyway, 5 factorial is the product of 5 times 4 times 3 times 2 times 1. Okay, that's 5 factorial. And if you wanted to do 20 factorial, for instance, these numbers get really big. That's 20 times 19 times 18 times 17 times, I'm not going to write them all out, times 2 times 1. There they are, all 20 of them, okay? Now, these numbers get huge when you start actually multiplying them out. Even up to 20 factorial is a gigantic number in the sense of what we're used to, okay? So, the factorial gives us the number of permutations. Kind of interesting. Let me see here, what can I erase? Well, I'll erase my movies. Oh, I didn't want to erase my movies, but I'm going to. All right. So, in as a general definition then, n factorial is equal to n times whatever n is. N could be any number, any natural number. Natural numbers, remember, are 1, 2, 3 up to infinity. So n times n minus 1 times n minus 2, dot, 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 times 2 times 1. Okay, so you start at n, go 1 less, 2 less, 3 less, 4 less, 5 less, until you get to 2 and 1, and then you're done. Okay? So that is the technical definition of a factorial for any number. Factorials are only really defined for the natural numbers, except we have one extra factorial that exists that we use as a separate definition. Also, you can't write also. Also, 0 factorial is defined to be the value of 1. Now there's a reason we choose the 1 as 0 factorial, and that is because it's useful. It's consistent with the pattern that you see in all the other factorials. If you think about it for just a moment, this wouldn't really make any sense because just thinking about it in this sense, using the products of natural numbers, well, 0 itself is not a natural number, and there are no natural numbers less than it, so it doesn't make any sense to use the other definition there. However, if you think about a pattern of the other factorials, we just did 5 factorial, that we know to be 120. 4 factorial is what you get if you basically take the 5 off of that. 4 times 3 is 12, times 2 is 24. And so to get from 120 to 24, like I said, you remove the 5, so you're dividing by 5 to go down that list. 3 factorial is what you get if you just have 3 times 2 times 1, which is 6. Well, that's a division by 4. That's removing the 4 off the list. And then if you have 2 factorial, well, that's 2 times 1, which is 2. That, of course, is division by 3, right? 6 divided by 3 gives you 2. And 1 factorial is obviously just 1. That's just that number. And of course, if you take and divide 2 by 2, you get 1. Well, so then the question is, if you go down one more to 0 factorial, what do you get? Well, if you divide by 5, 4, 3, 2, the next step would be to divide by 1, right? That makes sense. And so 1 divided by 1 would give you 1. Hence the definition, okay? Now, you could continue the pattern, right? What would it mean to say -1 factorial, right? If you kept going with this. Well, things break down at that point, because at that point, you'd have to divide by what? 5, 4, 3, 2, 1, 0. Division by 0 is undefined. Therefore, there is no negative factorial. Okay, -1 factorial. And therefore, there is no negative anything factorial. They just don't exist. So we're allowed to go down to 0 factorial, but not beyond that. Okay, at least that makes sense to me. So we allow all the natural numbers to have a factorial as the product of all the natural numbers up to that number, and 0 factorial is 1. Those two definitions make up all the definitions for a factorial. Factorials are key in working with permutations. Okay, so I'll explain an actual formula for developing permutations based upon a list or based upon this factorial definition and choosing items out of a list of other items.